Fractions and decimals, part 1. Fractions and decimals are just two different ways of writing the same number. Now, to change a fraction into a decimal, just divide the numerator, the top number, by the denominator, the bottom number. And sometimes when a fraction is converted into a decimal, it will become either a terminating or a repeating decimal. That's just the way it works. It either ends or it doesn't. But here, as an example, write each fraction as a decimal. So if I wanted to do that, all I would do is I'd say, well, how many times does 8, remember, this is just a division problem, 3 divided by 8. How many times does 3, or does 8 go into 3? Well, I know it's going to be less than 1, so, because 8 doesn't go into 3. So now I'm going to go ahead and go, well, 8, how many times does it go into 30? It goes in a total of, well, 24 is 8 times 3. So 6 is left over when I subtract. Now I bring this down. 8 goes into 60. How many times? It goes in a total of 7 times, because that's 56. But I still have 4, so I need to add one more 0 here and bring it down. So now 8 times 5 is equal to 40. So I have a terminating decimal because I've got no remainder left over. So that's great. I'm done. I've got this here is going to be my answer as to what the decimal equivalent of this number is going to be. Now, over here, 4 over 15, same thing. All I'm going to do is how many times does 15 go into 4? Well, 15 doesn't go into 4. Does 15 go into 40? Yes, it does. It goes in twice. It goes in 30. Now, does 15 go in 100? Yeah, of course it does. So it goes in, well, 15 goes in 90 is the biggest number, so 6 times 15 is 90. Subtract, I end up with 10. Okay, so now I got a little bit of a problem here. Look what's happening to me here. When I subtracted this, I ended up with 10. I'm going to bring this down. Okay, if you notice here, I still have that 100 there. So what's going to happen is, I'm going to keep on getting the same thing. And I can keep doing this forever, but I'm going to keep getting the same thing over and over again. Each time it's going to be 0.2666666. Now this is when we use what is called a vinculum. A vinculum is a fancy Latin word, and all it means is the bar over the top, and that indicates that this is a repeating decimal. That it goes on forever, it does not stop, and that's just the way it happens. Now, one thing, just as a heads up, you won't end up with a decimal that's a repeating decimal if you have numbers that are even, that are like only divisible by 2. But you will if you have certain odd numbers. Like right now, I know that this is going to be a repeating decimal. And I'll show you what I mean in terms of that. So if I look here, I'm just going to go ahead and erase this part here for a minute. If I look here, 7 divided by 9. Well, 9 doesn't go into 7. Let's speed this up a little bit here. 9 doesn't go into 7. 8 goes into 70, though. It goes in a total of 7 times. And when you do that, you end up with 63. And check it out. Oh, I got 70 again. So I know that it's just going to keep on going 0.7 because I'm going to keep getting that 70 each time I put another 7 up here. How many times does 11 go into How many times does 11 go into 9? And this is going to be another one of those ones that is going to be a repeating decimal. Because I think that those are actually a little bit harder to figure, so that's why we're spending a little bit more time on those. So 11 into 9. 11 into 9 doesn't go. 11 into 90, yeah, it does. 8. 8 times because 88. Now I'm left with 20. Okay, now, does 11 go into 20? Yeah, it does. It goes in one time. And now I'm back to 9. If you look back up here, you might figure this out. You are going to end up with a repeating decimal here. But it's not going to be the same number over and over again. It's going to be the same number with a couple of numbers repeating each other. And just let me show you what I mean. So 90. How many times does 11 go into 90? It goes in. One more time here. It goes in 8 times. And then we end up with 2 again. So it's going to end up with 8, 1, 8, 1, 8, 1, 8, 1. Now, the important thing to understand on this, with the vinculum, you need to put it over the 8 and the 1. Now, this problem up here, remember, it just went 0.26 and 66666 forever. You didn't put the vinculum over the 2 part. You just put it over the 6 because that's the thing that's repeating. Here, you're putting it over the 8 and the 1 because it's 8, 1, 8, 1, 8, 1, 8, 1 forever. And that's it.